Hey everyone, it's Berm, and this is Level 0 Networking. Today, we'll be making VyOS into an Application Aware Firewall using nprobe. So, why do you need an Application Aware Firewall? It's always been a challenge to block traffic at scale. When you compound that with internet traffic to specific services that may come from any number of IPs and hosts, the whole thing becomes a nightmare. There are a few approaches to solving this. You can use a proxy with content filtering, whitelist or blacklist, DNS filtering, and Layer 7 firewalls. This video is going to go over the latter. So, how does a Layer 7 firewall work? Layer 7 firewalls utilize a combination of deep packet inspection, or DPI, matching traffic to well-known ports or IPs, and inspecting DNS requests to help identify sites and services. In the world of Linux and FreeBSD routing, the primary DPI engine you'll see in most NOS software is NDPI, which you'll commonly find in tools like nprobe and ntopng. Our topology today is going to be simple. We'll have a VyOS box connected to the internet at the edge of our network. One of the best things VyOS did was add the ability to run containers with host networking. We are going to install nprobe to add the Layer 7 functionality we need. To do this, first we need to add the container image to VyOS. From operational mode, we want to add container image intop/nprobe:/latest. As you can see at the bottom. Let's go ahead and verify it's there by showing the container. We do that by show container image. As we can see, it's there. Now we'll drop into config mode and set up the container. First, we want to create the directory for nprobe. Next, let's go into configuration mode. nprobe uses NFQ to send traffic to the nprobe container and return a verdict, or mark the traffic for further processing like QoS. We create an NFQ of 25 that we'll call in a firewall rule later. Now, nprobe has a few different modes, but we specifically want to use it to allow or block traffic based on an identified application or group of applications. To do this, you need to create a rules file for filtering. So you point to that rules file here. This will be the directory within the container, not your VyOS host. The -n none will turn off sending flows to a NetFlow collector since we don't need that functionality. And finally, the -b1 switch will give us traffic statistics in the nprobe log. This can be useful for validating traffic. The rest of the commands are setting up access, the nprobe image, and mapping file system locations between the container and the host. We'll go ahead and commit and save. And we'll exit. Just for awareness, nprobe uses a JSON format to filter traffic. First thing we'll do is create the pool definition. To do this, we'll need to create and edit the IP rules configuration file. We'll need to create a unique pool ID for each pool definition we create. The policy ID at the end of the line states which of the policies to utilize for the pool. This first policy is our default policy. Since there isn't a pool configured for it, all traffic outside of the configured pool will fall under this policy. This policy blocks Twitch, but allows everything else. This next policy will block traffic identified as Facebook traffic. Putting all the parts together, this means that the 192.168.2.0/24 and 10.0.95.0/24 networks cannot access Facebook, but will be allowed to access everything else. Now we want to write the file and exit. A quick note, this is only a fraction of the match criteria for rules. You can also match on categories like social networks or streaming sites, as well as GeoIP data. You can even match on information inside of the site certificate to make sure it is secure. You can read more about nprobe IP rules at the link below for ntop.org. I'll make sure to put the link to the website in the description. Now let's go ahead and restart the container. This needs to be done in order to load the rules. It only needs to be restarted the first time you apply this. All subsequent rules will be picked up automatically. Next, we'll check the container to ensure our rules are there. And they are. Now, let's go ahead and move over to the desktops. Let's check our access to Facebook and Twitch. Desktop 1 falls within the defined rules set. However, Desktop 2 does not. We'll go ahead and open up Facebook on Desktop 1. We still have access to Facebook on Desktop 1. Now let's go over to Desktop 2. On Desktop 2, we're going to try to access Twitch. This connection is still working because we haven't pointed any firewall rules at nprobe yet. Now, let's head back to the CLI. This next step, we'll configure the forward chain to use nprobe. We'll head back into configuration mode again. As you can see, we're configuring the flow table called OT1. Here we'll set our interfaces to participate. Ethernet 0 is our external interface, and Ethernet 1 is our internal interface. Now, we'll configure the default action of drop. This will drop any traffic not matched by a rule. Rule 5 is leveraging the flow table feature in NF tables to create a fast path for packet filtering. Once a flow enters the flow table, it no longer needs to have each packet filtered, which speeds up filtering greatly. Traffic is allowed by this rule if there's already connection state for it. Rule 1000 explicitly allows all traffic from Ethernet 1. This is what will create the return state that is matched by Rule 5. Now, let's create the rule for sending traffic to nprobe. We set the action to queue, which tells NF tables to use NFQ. Then, we set the queue to 25, which is what we defined when we started the nprobe container earlier. We set the action to queue, which tells NF tables to use NFQ. We set the queue to 25, which is what we defined when we started the nprobe container. We set the queue options to bypass. What this means is if the container is down or unreachable, traffic will still be forwarded. This prevents traffic from black holing. But you can omit it if you actually want traffic to be black holed if it's down. Our packet flow would be like this. A user sends a packet and it's received on Ethernet 1. The packet is sent to the internet and sent back where it will hit the forward chain. Rule 5 will only offload traffic with an allowed state, which isn't present yet, so it skips Rule 5. Rule 10 is hit, which will send the traffic onto the nprobe container. The traffic will either be accepted or dropped. If the packet is accepted, then it will be added to the flow table, which will make subsequent filtering faster. Go ahead and commit our rules. Back on desktop 1, we'll head over to Facebook. As we can see, traffic is indeed being blocked to Facebook. Now, back on desktop 2, we'll check Twitch. Again, desktop 2 didn't fall within one of the rules, so Twitch should be blocked. As we can see, it is. Back over on the CLI, we're going to go ahead and check the logs. To do this, we're going to show log container nprobe. We're also going to egrep for L7 protocol, Twitch, and Facebook. As you can see, we can see the traffic in here. We can also look at the traffic estat with the following command. Show container log nprobe. I want to go ahead and mention a couple of limitations of nprobe. It'll install with a demo license by default. The demo license has a limitation of total flows exported and number of flows exported. The sensor for collection also expires after 300 seconds. There don't appear to be any limitations in IPS mode, and a 1 gig can fully be utilized. One general limitation of nprobe Pro is that it has a limit of 4 pools or rules. This doesn't make it unusable though, as you can chain a lot of pass and drop rules into one rule. You can also drop traffic categories, such as streaming. Thank you for stopping by and checking out the video. If you enjoy the content, make sure to like and subscribe for more in the future.